Well, guys, so I'm back and discussing further the principles of object-oriented programming in C#. We did start the discussion in the previous video, which was led to by 6 videos before that. So it will really help if you do watch all the videos. But in specific, if you want to know about object-oriented programming, especially in C#, then this video and the previous video, video 7 and 7.1 and 7.2 of the most importance. So we touched last time on the fact that we're going to try and place a car, a real world car, into a computer program, represented in a computer program. Now, we can't obviously represent every single nut and bolt and stuff at the moment. That's going to take too much time to do something like that, but that's ultimately what you'll use object-oriented programming for. So we just took a simple example of a car with some simple properties of it. And this video is just carrying on from where we left off last time. So if we go back to our old C# code from last time, remember, here's our class that we created in a namespace, in the model namespace on this side here. All right, we created an enumeration, and inside of that we've got an actual enum. So we created an enumeration folder. People sometimes call it just enum or enums, but enumerations is also often used. I normally just say enums, but you seldomly work on programs where you can just stick all your enumerations in one folder. Your smaller projects maybe, but your bigger ones not really. Anyway, so if we go back to our class here that we created last time, so we still got three hidden variables. In other words, object state that's hidden from us. There used to be 6, and we've exposed those other 6 through what we call properties. We've exposed that to the outside world. The moment you make a change in your class that makes it accessible from the outside world, you're saying you're changing your interface. Well, not necessarily if it's accessible or not, but if you make a change to your class which does add or subtract an object or function or whatever the case may be from what we call the API layer, in other words, the public interface that another developer can use on your class, then that's called changing the interface. And changing an interface can lead to a lot of problems if you've already finished designing your program and then want to make changes later. So your interface up front, you should really do a lot of thinking about. That's why, like last time, I mentioned to you that you can use variables, all right, and then write your own get and set functions to change them and retrieve the values. Alternatively, you can just create yourself some quick properties. And then at any point at a later stage, when you do want to make a change to have, for instance, validation and so forth, you can change it, for instance, in the set bit here, and the interface doesn't change. I mean, if you rename the name of a property, for instance, then it does change. If you add a new object to or a new function to the interface, that's typically okay, because the old methods, the old programs using your new class is not aware of your new function, so they'll still work fine. But then newer code that does need your code will also work fine because it's got the new function. Okay, so rambling on a bit there, sorry guys. And okay, so we've got some encapsulated data. We've got some properties to get to that data, and we've created a constructor to set one of those properties via injection. You'll come across that term many times. Injection through the constructor. Okay. Now, I think to explain some of the other concepts a little bit further, what I actually want to do is I want to take this engine that we've got here, which is of type string at the moment. So it's just going to be engine is, Ford V8, whatever. We don't really want the user to just type that in. We want to give them a few choices, okay, of engines. All right, so we might have only, let's say, 3 engines available in our factory. They've got different properties. So they will also have a base engine of or a base class of just called engine, which will mean it's got pistons. Well, unless you've got an electric engine, but I mean, it's got something like pistons, cubic inches, horsepower, and all those things are properties of that specific engine. But I want to show you how to use abstraction, and that's why I want to show you how we can get to this engine. So what we should do then is back on this side under model, all right? So it'll be on the same level as Hot Rod itself, all right? We're going to create another class, okay? Right mouse click on model, and we say add class. All right, it's going to ask us what the class is, and we just say engine. Okay, so just for interest's sake, you'll notice it's all highlighted here, class1.cs. If you just start typing, like I say engine, all right, and you forget to put the .cs back in, don't worry about it. C# will do it for you. So just type in the word engine and press enter. All right, it will then go ahead and create for us a engine class, which it's done, and it's in the same namespace as the Hot Rod class. In other words, my first application model. All right, so they're in the same name class, so they can quite easily talk to each other. All right, now the thing is, like I say, let's define a few parameters or properties of engines. Okay. Let's just normally put it up top here, but I'm just going to put it at the bottom here. So if we put in two forward slashes, you'll notice this is just considered text by C# now. It doesn't try to compile it or anything. It's similar. Let's say I've got, for instance, 4 lines. Okay, so it's 1, 2, 3, and 4. Okay, so let's say oh, come on. I want those 4 lines commented out. Okay, you could just select them all right, and say Control KC, and that'll comment them all out. All right, and to uncomment them again is Control KU, and it uncomments it again. All right, but you can do the commenting by hand as well. All right, just put a double slash in front of every line. Okay, that's the way we normally do it. All right, but there's another way you can do it as well. Okay, some other languages use this as well. Well, the forward slash many languages use as well, but okay, on this one then it's forward slash, okay, star, and then at the bottom it's the opposite, star forward slash, and everything between those two stars is going to be commented out. So in other words, not compiled, doesn't cause errors, it's just code that the developer can read. All right, so like I say, we're using this for properties for our engine. All right, to remind ourselves what they are. Let's just call them properties and underline it. All right, so the first property we've got on an engine, for instance, will be make. All right, yeah, let's call it make. All right, it could be a Ford, it could be Ferrari, it could be whatever the case may be. So let's call it manufacturer. All right, and then let's say we have something like number of pistons. Okay, so we say number of pistons. We might also want to say, for instance, cubic inches. All right, so cubic inches, and then lastly we could maybe say as a boolean it has a supercharger or turbo. So we'll just call it has charger or turbo, and that's a boolean. So let me just remind myself there. So that's a boolean. All right. So then so these are again. Let's just make this class public, because something outside of our library might need to use it. We'll discuss public and private and all that at some point later. So you defined a couple of points here, points of data, which can be hidden via encapsulation, such as, for instance, the manufacturer, number of pistons, cubic inches, and so forth. But in fact, I want all those things actually to be able to be controlled through properties in a constructor from the outside world. In other words, the person or the piece of code that is actually implementing our engine class the one that's actually going to create an instance of it. In this case, it's going to be ourselves, but in some case, it might be some other programmer creating an instance of your engine class, for instance. All right, so we're going to say immediately, okay, so I know manufacturer, I don't want it to be a string. I don't want them just to be able to type in any manufacturer. All right, I want to give them a list of manufacturers because my factory only deals with certain manufacturers. All right, so again, we're going to go to enumerations. Now remember, we've already got one enumeration under there, body material, okay, but we don't add into this file. Remember I said everything must be in a new file. So we go to enumerations again and we say add, all right, and we say class, and it is manufacturer. All right, so it's manufacturer. All right, so it'll go ahead and create us a manufacturer. Let's make it a public class. All right, sorry, a public enum. Okay, enums for enumeration. You'll notice the namespace, my first model, model.enumerations. So it's lying in the same place, on the same level as body materials, which is good. We want our enumerations to stay together, to live together. All right. So it's easier to find them that way if you're quickly looking for them. So we've got manufacturers. So let's say we've got a couple of manufacturers here. Let's say we have Ford, okay, and we have Ferrari. I don't even know how to spell Ferrari, but alright, let's hope that's right. And we have Audi. We have Audi. We have BMW. And we have Jaguar. And finally, let's say we have, for instance, a Pontiac. Alright. And those are our manufacturers, so they declared, all right, they live inside the manufacturer.cs file. The .cs just stands for .c#. So if you see a file that says whatever .cs, then you know it's a C# file. Okay, contains C# text inside of it, all right. So let's just close our, let's just go to a hot rod again. Okay, so remember now this engine, all right, we don't want it to be a string anymore, to be an actual instance of our engine class, which is what we're creating here. Okay, so now I want to say, all right, I want a property on this engine, which is the manufacturer. All right, so remember a quick way to put in a property, public, and then we have to specify the data type. All right, this is classes are data types. All right, they're just data types you created yourself. Like an integer is a data type. This is a data type you created yourself. So you'll also later we'll also refer to structs and so forth, and that's a different type of data type, but very similar to a class. But we'll cover that maybe at some point. We'll see. All right, so we want to create a public property on our engine object. So it's public property. Then it's going to be under enumerations. All right, and it's going to be manufacturer. We're going to call our property manufacturer, just because it makes sense calling him that, because that's what he is a manufacturer. Okay, oops, and then we say get set on that, get and set. All right, so now we've created a property, all right, that's publicly visible, that sets the manufacturer, and the manufacturer can only be one of those in the enumeration manufacturer. So in other words, what we created just now, already Pontiac, Ford, BMW, etc. All right. But now let's say when at some point that thing must be created. So we don't want somebody to create an instance of our engine, create an object of our engine, and then forget to set the manufacturer type. So we have this car with an object and we don't know who made the engine. That should never be allowed. The moment you create an instance of an engine, you must say what engine it is. So the easiest way to do that is through your constructor. So, okay, we make that public. All right, and remember, for a constructor, there's no return type, and the method name or the constructor name is the same as that of the name of the class. So in this case, engine. All right, and open, close, and squigglies. All right, so there we've overridden our base constructor, the one that the .NET Framework creates for us anyway. We've overridden that now, but now we're going to go and add an additional one. All right, so we're actually going to leave this one that's got no parameters there. We're going to leave that original one alone and not override that anymore. We're going to add a new one. Okay, so the way you do that is by changing your parameters versus one that's already in existence that you're overriding, which is what we're going to do now. We're going to add a parameter. So what we want to do is when somebody creates an instance of our engine, one of the first things they must do is they must tell us who's the manufacturer. All right, so in other words, we must take a data type, you know, like a string or enumerations dot, okay, manufacturer, okay, dot, and and then we just say manufacturer. All right, so if somebody creates an instance of an engine, he has to tell us who the manufacturer is. All right, and then you just say this dot, and then your manufacturer object over here, your property, okay, you just say this dot manufacturer equals the manufacturer that's just coming in from the parameter up top here, okay, in the constructor. So we've basically created an engine, okay, class. Okay, it's got one property on it, which is an enumeration of type manufacturer, and it's got a constructor which takes a parameter which is the manufacturer and sets the internal manufacturer to that. So if after this engine was created, if we ask him, okay, what is the value of manufacturer, he's going to give us the value that it was created with in the constructor. So if he made it, let's say Ford, and then at any point later in time we ask him, so who's your manufacturer, he's going to give us the enumeration answer of Ford. Okay, so now, okay, so that kills manufacturer. We don't need manufacturer here anymore. All right, and then you can have, for instance, number of pistons. Now, but in this case, we're going to make it a byte, okay, and we do want some validation on it. Then the name of our property, number of pistons, okay, and then we want a get set. Oops, squigglies. Okay, in the get we want to return this dot number of pistons. Now remember, this dot number of pistons doesn't exist yet. All right, so we create a hidden variable. Okay, so it's private. Okay, so number of pistons, which is of type byte. Okay, and we start off, it's not. Okay, we could put a default in and say, let's say 4. So if nobody ever sets the number of pistons, then it's 4. Okay, if you ever query how many pistons are there in this engine, it'll say 4. But we want somebody to specifically set it. So we put in that on naught, and so sorry, we must just close that. And all right, and then when we set it, we want to say, okay, we only want to set it if there are between 1 and 12 cylinders, but only certain ones. So let's say, for instance, if okay, this dot number of pistons is equal to let's say 1. You can have a car with, or an engine with 1 piston, that's okay. Let's assume, all right. But we also want, there might be more than 1, there might be 2, okay. So we'd say or this dot number of pistons equals 2. And so you can say or, but what we normally do is we just put this or on a new line, all right. And so it's easier just to keep track of your stuff like this, else they sometimes flow off the end of the screen. Okay, this that number of pistons equals, let's say we can also have 4. Okay, this is a comparison, not a set. All right. So we're currently allowed to have 1, 2, or 4, and I think we'll also allow 8, 6, 8, 10, and a 12. All right. So it's well, obviously we need a 4, okay, and a 6, and an 8, and a 10, and a 12. Let's say. All right. So that's the number of pistons that are allowed. All right. Now, if it isn't one of okay, so if it is one of those, all right, then we say, okay, this dot number of pistons equals value. Okay. Oh, okay. You can see I made a mistake here. Okay. On the set, you must remember the data that we're setting something to is the value, not the name here. This is supposed to be value. My mistake. All right. But so we get caught out from time to time, even with our own stuff. So, all right. So all these must be changed to value. All right. So almost done. Okay, so there we go. All right, so what this thing is saying is, okay, set up the property, okay, called this dot number of pistons, set its value if the value is a 1, 2, 4, 6, 8, 10, or 12. So that's how many cylinders we allow in one of our engines. All right. Okay, so, but if it's not, all right, then this program must scream to us. It must say, no, this whole thing is wrong. It's going to fall over. It's just the world has come to an end. We don't want this to happen. So what you can do in that case is then throw an exception. All right. This is not necessarily the best way to do it at all. They say don't code by exceptions. Don't do error handling via exceptions. But in this case, I'm just going to show you how an exception works. Now, exception sort of just throws its hands in the air, and the program says, whoa, I don't know what to do further. And something must handle that exception. And if nothing handles it, your program will just crash. Okay? But like what's going to happen with us, there's nothing going to handle this exception either. So what we say is, all right, so else, okay, so then we say throw, which we want to throw an exception. That's what you call it when you raise this exception. You say throw new, or we say new because it's a class, okay, same as our engine and so forth. Throw new exception, and then in the constructor of that exception, we want to send a message and say not valid piston count. All right. So this program will fail if somebody tries to put in any value other than one of these values, okay, as a piston number, as a number of pistons. Okay, so we've got now, we've got a private encapsulated bit of data, all right, but it is exposed through the use of a property, okay, on which we've done some validation in that property. Okay, and then we also have another data type, which is the manufacturer, but we did no validation on that because we don't have to, because the type of data that we allow it to be is an enumeration, which only allows you to use the values in the enumeration. So in that sense, you know, the mere fact that it's an enumeration, we've already basically done, you know, checking to see if it's a valid value or not. All right, so we don't need to worry about something similar to like we did down here. You could go and create another enum, for instance, pistons, of which your values are 1, 2, 4, 6, 8, and 10. And then you can say, yeah, enumerations instead of dot manufacturer, but enumerations dot pistons. And then, you know, then you don't have to worry about this. But I'm just showing you can use an enum and do validate because of its existence within itself. It does data validation. Alternatively, in your property, you can do data validation. Okay, so now what I want to do is I actually want to build out this engine because I want to show you abstraction. All right. So we're working on this engine. Something else that you might be interested in, what I sometimes do, all right, is I create regions. All right. Come now. So let's say hash region. Fuels. Okay, and then All right. So what it does is it creates this little region here, which I can drop and close. All right. And so now I know all my fields, or my hidden variables, live inside this little bit here. This is not a class. This is not a namespace. It does nothing except just put things together so that you can collapse and expand them. It's the only reason it exists. It just makes it easier to look at your code. So for instance, then after regions, after fields, I normally have my next region, all right, hash region, which is called properties. All right, misspelled region here. Okay, so I'll have to indent it myself then. All right, and then when I get to the end of my properties here, all right, I say hash end region. Okay, and I'm going to indent it. All right, sorry for end region. Okay, so now if I go to regions up top here, properties up top here, and I say drop, all right, all the fields are gone. All the fields and all the properties, they're not gone, they just collapse. You can't see them. So if I want to look at just my fields, I can open just my fields. If I want to look at just my properties, I can open just my properties. I'll even go so far as with my constructors in there. And hash end region, can you believe it? Hash region, let's call it constructors. You see, you can have more than one constructor as a by the way. And then after that we have hash end region. Okay, so now we've got 3 regions: fields, properties, and constructors. So instead of looking at hundreds of lines of code, I might just say, I'll just drop everything. Looks much neater, and I just quickly want to work on the constructor. So I open up just my constructors. There might be more than one, like I say, but I open up my constructors. So all right, now on the constructor, remember we wanted to say that the person must be able to tell us. Okay, so that's the manufacturer. So that's the number of pistons. Okay. We made that a property. But okay, so someone can set this number of pistons after they've created an instance of this object. But let's say we don't really want that. We want it only when they create the object the first time. All right. So what that means is when we go to our get and our setter, we want to allow anyone to do a get. In other words, to ask us how many pistons are there. But they cannot change it. All right, they may change it. They may just ask us. They may only change it when they create the engine the first time, and they call the constructor. So what I'm saying is, so the get is public, all right, but the set is private. Okay, so no one except this class itself can get to it. All right. So what that allows us to do is, if we come here to engine, all right, we can now send it. Okay, what is that data type? Is of type byte. All right, so we can now send it a byte, and it's called, let's say, number of pistons. Okay, and then down here, after we've set the manufacturer, we say this dot, now the property name starts with a capital, number of pistons, equals, and then the value we just sent through as a parameter, which is number of pistons. All right, and that's it. All right, now that'll work. All right, but if you try and run this code and you give them the wrong number of pistons, so in this value here, if you send the value of 23, it will continue to this point, and then it'll get here and it'll fall over, because when you set it, it comes in here to the set bit, and it looks at this evaluation here, and it sees that isn't any one. Let's say the value is 20. Sees it isn't any one of these. So he jumps into the else, okay, because the Boolean expression failed, okay, evaluation failed, and it goes to this throw new exception. So so your program will crash at this point. All right. Now ultimately you should handle this properly. We can discuss that maybe in another point. Okay, and all right, so we've got number of we've got manufacturer, number of pistons, cubic inches. I'll just do that very quickly for us, so we don't have to struggle with all this. All right, so what I quickly did for us is I just added cubic inches as well as has a charger or a supercharger or turbo as well. Now, the cubic inches must also be set, all right, when you first create this instance of your engine. All right, so we add another parameter to the constructor. Okay. Okay, so we say, so that is I made of data type single, because it could be a floating point number, you know, 8.3 liter or something like that, or 4.6, 4.2, etc. All right, so and we just call that a descriptive name. All right, so we know what we're dealing with, cubic inches. All right, and at the bottom here we can come and say this dot cubic inches, which is the property, is equal to cubic inches. All right, now I did no validation on this cubic inches. I just set the property directly. You can, the same as what I did here, you can put validation on of saying, you know, it's got to be between, you know, a 1 liter and a 12 liter, or, you know, between 30 cubic inches and whatever, or you can make it an enum as well. There's many ways you can do your validation, but I've shown them to you now already. So okay, so we've got our class, and let's just kill all our properties. Okay, so there's our constructor. All right, now just for interest's sake, all right, I'm going to show you how you can use more than one constructor. All right, if we copy this constructor, okay, so we know I've got a copy of it, and it's going to complain to us. Okay, and it's going to tell us, remember, you would think now, because within the same namespace, or within the same module, all right, so like in this class, in this case, in the class engine, we've created two constructors with the same name, which is not allowed. All right, the only time you're allowed to have two methods or two functions or constructors with the same name is if the parameters are different. Okay, so let me delete, for instance, these last two. Okay, on the second constructor, and suddenly everything will be okay. All right, in the naming here. All right, but okay, it still has a bit of a problem. All right, it does not know cubic inches for inch. It doesn't know how it's set. Where is it set? We seem to have a little problem here. How does this know where it comes from? Okay, yeah, this should be, I should have given this a different name. This is where I like using my underscores. Okay, then I know for a fact what I'm actually dealing with. Okay, so anywhere from now on, if I use number of pistons, I put an underscore in front of it, then I know I'm referring to the field one, all right, the hidden data one. But if there isn't an underscore, then I know it's either a local variable or it comes in as a parameter. So which is this case, okay, it's supposed to come in as a parameter, but it's not. It's not being sent in. All right. So, but in the original constructor, we sent in 3 parameters. All right. The manufacturer, the number of pistons, and cubic inches. And so it could set those values. But let's say, for instance, you also have a constructor. So you've got now 2 constructors, right? Where the guy, when somebody creates a new version of your engine, you say, okay, don't worry, you don't have to tell me how many pistons there are, and you don't have to tell me how many cubic inches there are. All right, I will either decide, and I will say, okay, I'm going to make it 8 pistons. All right, and let's say 400 cubic inches or whatever. Okay. Or you could just mean to not set anything. So you're giving him the option to create an engine, giving him all the details of the engine, or creating an engine, but the details are not complete. And he, as the programmer, should know at some point, you must actually call the properties to set those correct values. Okay, just because I made that underscore, it's got to be made underscore here as well. See this underscore here. All right. Okay, so I hope I'm not getting too in depth here, but I'm trying to give you so much information that if you do catch on to this, that you can actually write real classes and do well in your career. But there's so much to cover. Object-oriented programming is actually extremely simple, but it's so powerful that if you're not careful, you can run down a rabbit hole. and but it can make you do amazing stuff easily, very easily. Okay, so we've got two constructors now for the engine. Okay, so if we come to our hot rod, all right, yes, our hot rod. Okay, remember we had this variable up top here, this encapsulated bit of data called engine. All right, let's say that we now actually want this engine to be set. All right, when the hot rod gets created. All right, and it's no longer a string. Remember, it is now of type class engine. Okay, so I just want to keep things by the same area. I like my underlines in my fields. All right, and that's all good. And you don't have to do that, but there are still some of us that, some of the older programmers that still like doing that. Okay, so this engine now, firstly, is no longer of type string. Okay, that's going to cause us a problem. We actually want it to be of type engine. All right, so it is of type engine. Now you don't have to give a namespace in front of the word engine, because hot rod and engine, if you look here, hot rod and engine are both inside the same namespace. Okay, they both live under model. All right, so they're in the same namespace. So if you look at hot rod, the namespace is my first application model, and if you look at engine, my first application is model. So they can just talk directly to each other. All right, so you don't have to specify a namespace or anything. So I'm saying I want to create an engine. Okay, its name is underscore engine. All right, it is private. All right, it is private. Okay, for now. All right, and then I'm trying to set it to a string, which obviously I can't do. All right, because it's an object. Okay, it's not a string, it's an engine object. So I can either at this point decide to create a new engine. Okay, alternatively I can just say it equals null. All right, so it's not set. All right, so if anyone tries to use that engine now in any code anywhere, this thing is going to crash because that engine is not set. It's got to be set somewhere. All right, so what we're going to do is we're going to set that in our constructor. Now it feels to me like an engine is more important than body materials, so instead of adding it to the end of the list of parameters here, I'm going to add it to the front. So I'm going to say, okay, so we want to send in an engine, remember a data type engine, a class engine, an object engine. All right, engine, and we're just going to call it engine. Okay, and then down here we're going to set the property this dot engine. Yes, that is what I called it, engine. Okay, oh come on, engine equals engine. All right, okay, so now sorry, we need a comma here. Okay, so what we've done now is we've created a class. Okay, so that when somebody wants to create an instance of a hot rod, he has to specify the engine and also the body material. Okay, but the problem now is he can never do anything with that engine. Remember, it's private. Okay, so he can't ask the engine, for instance, well, okay, how many cylinders have you got? Okay, you can't do that because the engine is not part of the public interface. You can set it, you can send it into the constructor, but it doesn't mean you can get to the variable that it's set to inside. In other words, this variable up top here. Okay, so in some cases you might want to obviously do that. In many cases you do. Okay, now I'm going to show you, this is where abstraction comes in. Okay, instead of giving you direct access to that engine, okay, and on that engine you can then say, for instance, dot has charger or not, and it must return a true or false. Okay, well, let me show you how to do that, and then I'm going to explain to you that that is the incorrect way of doing it, thanks to something called the law of Demeter, and also, well, that's abstraction, so one of the tenets of object-oriented programming. So let's say the engine, we're going to change to a public property. All right, so it is no longer private, it is public. Okay, the name is no longer underscore engine, but capital engine. It's okay that the data type and the property type is the same. C# knows which one is which. He knows the first one is a data type and the second one is just the name of your property, or a variable, or whatever you want it to be. All right, and then we just do a get set on it. Get and set. All right, but let's say we only want, we only want this person to do a, let's just put it down here. Okay, keep our stuff together. All right, now I typically use regions here now, but okay. So we want him to be able to set the engine, all right, through by calling the constructor. You can never set the engine after that again, all right. But maybe he's working on the engine, okay, and the engine falls out of the car and breaks it off. Now he's got to put a new engine in, and he phones the owner and he says, oh, well, the engine broke. And the owner says, well, hey, this is a good chance for us to put in a more powerful engine. So what I'm saying is that engine that this object has might actually change, all right? So it's okay to set the engine from the outside world, because that might be a scenario where we would want to do that, okay? So where we can set the engine. But all right, so in other words, on our property, okay, we've got a get and a set. So you can get the engine, you can get a copy of the engine, and you can also set a copy of the engine. All right, so this has changed now, no longer a field, and that's all done fine. All right, so if we come back to our program now, all right, now you'll notice he's complaining on our constructor of the hot rod, and that is because we haven't specified the engine. Remember, I said we changed the constructor, all right, to require an engine as the first parameter, which wasn't the case previously. So we've got to then give him a new engine, all right? So let's just create a new variable, all right? And okay, in this case now, it's lying in a different namespace. It's lying under model, okay? Model dot engine equals, let's call it Ferrari engine. Okay, that's the name of our variable. Equals new, because we're dealing with a class. Okay, new model engine. He does suggest for us how to finish it, but yes, we want to create a new engine. Then he wants parameters because of the constructor, all right, and he only wants one. He wants the manufacturer, all right. So now it tells us it's lying under model.enumeration, so we can see it here in this drop down. All right, so we can double click on that, all right, and it'll put that model enumerations manufacturer there. But remember, it's an enum, so you've got to say dot and who's the manufacturer. And you say, well, I did say it's Ferrari because I decided to call my variable Ferrari, so well then it's Ferrari. So the manufacturer type is Ferrari, and end that with a semicolon. All right, so we've created the engine, all right. So we take the copy of that variable. Now under hot rod, okay, remember his first parameter must be the engine, all right. So we just paste our engine in there, all right, and it'll be fine, it'll be happy. So what we've done is we've created a real engine, all right, a Ferrari engine. We've created a hot rod which uses that Ferrari engine, okay, and its body is made out of steel, all right. And then you can say, okay, well, at this point it wasn't painted yet, okay. But you might want to say, okay, you might at some point in your program, you might want to say, okay, well, I need to paint it. So it's my super hot rod dot, where do we have number of doors? Oh, we don't have paint here. Looks like paint is still, we haven't made paint public. Okay, but okay, so we have got, for instance, number of doors, which is public. All right, and we say, okay, we start off with only 2 doors. All right, so we didn't specify that in the constructor. We didn't say we need to. All right, when we created the constructor, we just said we need the engine and the body material. So later we went and we set the number of doors. Okay, now according to your program, this might be fine or not fine, but often you set things up front in your constructor to make sure that it's a valid object. Okay, now what I'm getting at is with abstraction, okay, with that engine that we got, all right. So that engine, let's say for instance, let's see what properties we got on it. So it's Ferrari engine dot, and it tells us we've got a couple of properties here. So like cubic inches and so forth. Now, if I want to know how many pistons do you have? Okay. So let's create a variable. I think it's a byte. We just call it number pistons equals Ferrari number of pistons. Okay. So what's happened is we've queried this Ferrari object directly, all right, for its number of pistons, which is fine. You can do that. Okay. But the thing is, let's say that's if you're dealing directly with a Ferrari object. But once the Ferrari object now becomes part of the hot rod, in other words, it's now inside the hot rod. You've now created an instance of the hot rod using this Ferrari engine. All right. If you go to my super hot rod, engine, all right, so we know that this is the Ferrari engine, and we also say dot number of pistons, all right. That'll also work, and that'll tell us the exact engine that is inside our hot rod. How many pistons does it have? Now that works, it's fine, but one must be careful of this, all right. There's a lot of problems that you can run into with this. And there's ways of getting around it, okay, using something called the proxy pattern and so forth. But when it comes to object-oriented programming specific, this is what abstraction covers, okay? So remember there was the 4 tenets, of which one of those tenets is abstraction. So we should not allow the user to have direct access to our engine. You can have access to an engine he's created outside, fine, he's in control of that. But once he put that in our hot rod, in my super hot rod, he must not be able to change that engine. Okay, so we don't want him to get to it. So this is not the perfect solution, but it'll get the concept across. So this engine here must be hidden. So in the hot rod class. In the hot rod class, the engine is currently public. It must not be. It must be hidden. All right. So if we go look at it, all right, you'll see in the hot rod class, there's the engine and it's public. All right. And that's why we could call it directly and find out the number of pistons. Cylinders or whatever. I can't remember. All right. So what we want to do is actually make that private. Okay. So again, it's encapsulated data that's hidden. All right. But now, if we go back to our code here, we'll see there's an error. You can't get the number of pistons for the engine anymore. Why? Because the engine is now hidden. It's private. You can't get to it. All right. So, but how can I get my number of pistons? Well, what you can then do is create a class, a function, on hot rod. All right. And this is not a construct anymore. This is now a normal public function. Okay. And we'll just say get number of pistons. Okay, and its return type will therefore be a byte. Okay, get number of pistons. It takes no parameters or anything. All it does do is return. Okay, this dot engine dot number of pistons. Okay. So now again, we've got a way of getting to our pistons, okay, to read how many there are. But engine is missing. We still can't get to engine, all right? Engine doesn't exist, all right? But we do have a new method, okay, on my super hot rod. So if we say dot, it'll say get number of pistons, okay? And just open close brackets, because that's how you call a function, even if there are no parameters. And boom, it works. It tells you what your number of pistons are. So what we've done is we've actually put something between the user of your class, okay, the consumer, that's what we normally refer to it as, the consumer of your class. We've put a gap, a space between that and the actual engine. All right. So that guy, the consumer doesn't actually have direct access to your engine. The more astute among you, they already know some how classes work and so forth, might notice the fact that yes, I can change it on here, which will change it inside the hot rod. Yes, but that's not what I'm showing now. There's ways to get around that. But the principle is that you shouldn't let somebody have direct access to one of your internal objects, in other words, an engine, and work on it. Because if that interface of that internal object changes, then everything that was using your class also has to change. Whereas all you need to do is only change your class. So, so if they always only call this get number of pistons, and let's say it's for some reason it's no longer called engine anymore, it's called hot rod engine, okay, or best engine in the world, all right, whatever the class name is, because you've changed it, you can't say here, for instance, engine dot number of pistons like we tried just now, all right. It's now going to be changed to the best engine in the world dot number of. So that means just because somebody went and changed the name of a class, everybody, that even the people using your class, has to go and update their code. But if you just expose that method or that number of pistons in one of your own methods, the only place, okay, where a class name change is going to be affected is inside your method that you just created. So this engine here will now be called whatever the new name is. All right. So everyone that's calling your code won't fall over. All right. And that's basically the idea of abstraction. Okay. Okay. The very last thing that we're going to approach now is interfaces and polymorphism. Okay. Polymorphism is quite nifty. Something really great. I'm just thinking, I think the car is going to be a little bit too much info if we're going to do that. What I'm going to do is, let's restart. We're not going to we're working on a hot rod anymore. We're going to be working on an animal. All right. So let's delete the hot rod class. Let's delete the engine class. Come on, delete. Silly, I should have just deleted the entire model. Well, actually, the animal is going to go into there. So we might want to leave the enumerations there, but we do want to get rid of, let's just kill property. Okay, so let's delete that. All right. So now all we've really got is still one function, all right, full of errors. Now everything is sorted because we got rid of all the hot rod stuff that we were working on. Let's say we want to, for instance, work with, let's say birds, okay? Birds are animals, okay? So if somebody comes here and says, we have a zoo and we would like to have a virtual bird or whatever the animal is in a particular, sadly enough, cage in our zoo, we want to have a digital representation of that so people can come and on a computer come and look at the animal as well, and it must be told via GPS maybe where in the cage the animal is, so when they look at the screen it lights up the animal where it's lying in red, and then when they look at the actual cage they know it's under that tree or behind that rock or whatever. So that's a good use case for where you would want to use objects, for instance, because you're working with animals. Animals are objects. All right. Now, I can tell you immediately that we've already got one parent class that other classes can inherit from. And that is, for instance, a class called of type animal. All right. So let's just create under model. All right. We create an animal. Add class. All right. And we say animal. Just say enter. All right. And animal has got, let's say, certain properties, all right? They all have eyes, etc. Okay, so let's not worry about too much validations and so forth now. Let's just get the basic idea over. So I'm just going to create a variable, and it's going to be called, it's going to have a data type of type byte, because it's only going to have a very small number in it. We could create our own data type for like eyes. It could be an enumeration, for instance. So if we say like 2 eyes or 4 eyes or 6 eyes or whatever the case may be, then that's some way of doing validation. But we've already looked at that, so let's just do this the quick way. All right, we're not too worried about validation now. So public byte eyes count, or let's call it number of eyes. Come on, number of eyes. All right, and we do a get set on that. Okay, and we now have a backing variable of public eyes, and we've got a get and a set on it. All right. So what else does an animal have? All right. Let's refer to, when we say animal, we're referring to larger animals. You know, like mammals and birds and, you know, reptiles. You know, the larger animals we typically see. You know, snakes and so on. Not spiders and, you know, tardigrades and, you know, these kind of things, and bacteria and whatever. Just the large animals that we normally see. All right, so we can say it's got a number of eyes. Okay. Now you could say number of legs. Okay. And a valid value of that will be 0. Okay, because snakes don't have legs. Other things do, but snakes don't have legs. All right. So birds have 2. Dogs have 4. Okay. So, but that is a property that we can add to an animal. Okay, so it's number of legs. All right. So what else can an animal have? Like, let's say it can hear. It can. Does it have ears? You know. Okay. Well, these are all the simple ones. We can add many simple ones. Let's get to something a little bit more complex. Okay. So what we can have on here, all right, is a method, a function that says this creature must now move, whether it be walk or fly or slither or whatever, but it must move, okay, at a certain speed for a certain amount of, say, centimeters. All right. So we've got a function on here. All right. Sorry, public. Why am I typing the word function? Public. Okay, public void. All right, move. Okay, we can't say fly or walk or whatever because we don't know which animal this is. So this is just a generic thing. It's just move. Okay, so it's move, and it's got to move forward by a certain meters per second or whatever. Let's say so it's a u int. It could be a small one, u int 16. Speed in meters per second. Okay. Oh, my spelling. Speed in meters. There we go. Speed in meters per second, and then we also have, let's say, a u in 16, which is distance. Okay, distance. All right, and let's make a function out of that. All right, so at some point it can be called. Okay, move. All right. Now we're going to be talking about abstract classes and so forth now, but let's just do just this. Okay. So we've got an animal, okay, it's got a couple of eyes, got a couple of legs, and it can move. All right. So let's say I want to, for instance, create another type of animal. All right, a bird. Okay, that's based that is also just an animal. It's based off a normal animal, so it inherits the properties of a normal animal. All right. So let's say, for instance, under model next to animal, we create a new type. A new class, okay, which is let's say bird. All right, press enter. Okay, you'll notice it's also in the same namespace model as animal is. A bird and animal are both in the same namespace. All right, so we want to say, okay, so bird must inherit all the features that an animal has. Okay, so you do that with a colon here. Okay. And then animal, there we go. All right. So that's it. Bird is now an animal. Okay. So if you go to your program at top here, all right, and you want to create, for instance, a new animal, all right. Now, let's say, for instance, you can't create an animal directly, all right, because the animal itself is not really anything, all right, and even a bird itself isn't really anything. You say which bird, okay? It's a swallow, you know. It's some giant eagle or vulture, but just the bird on its own can't really exist. You've got to say which bird it is, which you can maybe do through an enumeration. In other words, on a bird, we can do that. All right, but so if I just create an instance of an animal, all right, so if I say, so it's in model dot animal, okay, and I'll just call it my animal equals new, all right, it's animal, and remember we didn't create any constructors, all right, so it just uses its default constructor, which takes no parameters. All right, so now we've got my animal. All right, now if I want to see what properties are available on that my animal, so it's my animal, and I press dot, all right, it'll tell me I've got move, number of eyes, and number of legs, because that's what we said is public. It's the public interface of an animal, all right. But now let's say, for instance, I don't create an animal, I create a bird, all right. Now remember, those were properties of an animal, but now we're dealing with a bird. Okay, bird, and if I say my bird dot, all right, it's also got move, number of eyes, and number of legs. Why is that? It's because we said a bird inherits from an animal. We go to bird, okay, we said the bird inherits from an animal. All right, you can only inherit from one other object, as a by the way, but in C# that is. So a bird is an animal, okay. So when we mentioned our principles of object-oriented programming, this is an example of is a, not has a relationship between bird and animal. All right, and if it's a is a relationship, then that's referring to inheritance. Okay, so we have, in other words, our bird. But let's say now, let's leave this as is. Let's get rid of this inheritance. Let's say now we're no longer inheriting from animal anymore. All right. Now remember, bird, all right, had those like move and number of eyes or whatever. So if I press dot now again, all right, they're not there. They're gone. All right. It's because it doesn't inherit from animal. Okay, so that's inheritance. So we want to go back to animal, to bird, and say yes, no, inherit from animal. All right, so if we come back here, we press our little, we look at our, okay, there, so there we have move, a number of eyes, a number of legs. So any creature that inherits from animal will have eyes and so forth, okay, and we'll be able to move. But then you can say the same thing. You can create another creature, like let's say it's a very specific type of bird. Let's say it's a penguin, okay. So you create a new class called penguin, and it inherits from bird, okay. So penguin inherits from bird, and bird inherits from animal. So therefore, a penguin will have all the features that animal has got. All right. So to prove to you how it just flows, it cascades down. All right, let's create now another animal. Okay, this is now going to be a real bird. Okay, let's call it a parrot. Which one ever, doesn't matter. So we created a parrot. All right, and the parrot inherits from bird. All right. So parrot is now a bird, okay? So on animal, remember you've got number of eyes, number of legs, and move. So if and on bird, we just inherited from animal. So bird must also have eyes and legs and move, okay? And parrot inherits from bird. So parrot must also have the same inherited functions and properties. All right, so let's go and see that. All right, so let's create, for instance, a parrot, my.parrot. Okay, and we'll just call it parrot, and we'll say equals new parrot. All right, so if I now say parrot dot, you should see move and etc. And there we have, there's move, number of eyes, and number of legs. All right, so even though we created that in animal, bird inherited from animal and parrot inherited from bird. So therefore parrot goes all the animal functions as well. All right, and therefore parrot also has a move function, and it can move. Okay, now something that might be unique, for instance, to a bird, all right, not an animal, all right, is, for instance, wingspan. Okay, so we know birds have got wings, all right. Animals don't necessarily have wings. So saying what's the wingspan of an animal, you shouldn't be asking that question. You should rather create an animal that's got common animal properties that things can inherit from. But when it comes to a bird, then you can say, okay, what is the wingspan? So let's just create a quick a property for that. We'll call it also a byte, and then it is wingspan, you know me, wingspan in meters. Oh, I've been up for too many hours. Wingspan in meters. Okay, wingspan in meters. All right, and we do a get set on it. All right, so now we have only on the bird, we have something called the wingspan in meters. Okay, so if you come look at our program again, all right. So, well, parrot is a bird, all right. So if we say dot now, we should see wingspan in meters, all right. And there it is, wingspan in meters. Okay, but if you create an object of type just animal, okay, come on, model dot animal, just call it a for now, equals new, all right, new animal. Okay, so we say a dot, there should be no wingspan, right? There's no wingspan, because wingspan does not belong to an animal. Okay, it belongs to a bird. All right, so if you go look at bird again, there's wingspan. Okay, just like now you can have, for instance, for a parrot, you can have something very specific which only a parrot has and other birds don't have. But all parrots have this one feature in common. So in other words, when you do create parrots, all of them can inherit from this parrot, okay, which has got its one special feature here. All right, and all the parrots will then inherit that. Okay, and that's inheritance. Okay, so passing down parameters or data, but from parent objects to child objects. But there can always only be one parent. That is inheritance in C#. In some other languages like C++, you can have multiple inheritance. There's good and bad to having both cases. So yeah, but in C# you don't really have a choice. In C++, for instance, you can choose to only inherit from only one object, but if you want more, you can. In C++, in C# you don't have the option. It's one other object and that's it. What you can, however, do in C# though is to inherit from multiple interfaces. Now, just a quick explanation of what an interface is basically anything. Let's take a class as an example. Anything that's got a public facing set of properties, functions, and so forth is called its interface. In other words, that which it makes available for other objects to deal with it. So for instance, if we go look at, let's see, maybe Parrot here. No. Well, I mean, if we go to animal, animal, all right. Animal has got a public interface. All these publics here. So number of eyes, number of legs, and void. Okay, that's all part of its public interface. You can obviously have privates in there, and that's not part of its public interface. It's just that which is specified as public. All right. So what I'm saying is, in C#, if let's go to our Parrot, for instance. All right. It might, for instance, you know, like it inherits from bird, which inherits from animal. So therefore, its public interface is the same as the public interface of bird, and as the same as animal. Which means you can talk to Parrot as if it's a bird or if it's an animal. So to demonstrate what I'm saying is, I'm going to add an interface, all right, to Parrot. All right, let's call it, for instance, let's base it on the fact that it's a nut eater and a fruit eater. Let's just call it a fruit eater. All right, so what we're going to do is we're going to create an interface called fruit eater, and all fruit eater birds must implement this interface. So let's create it. So we'll call it fruit eater. All right, oops, eater, and just copy that so I don't make spelling mistakes further, which I already did. All right, so it says at the moment fruit eater doesn't exist, which is correct, it doesn't exist. So we'll right mouse click again on model, and then you can say add new item, and then you'll find here's interface. All right, you click on interface, you type in your interface, and you say add. All right, but there's another way you can do it, which is a little bit less clicking. All right, there's basically no difference in what C# does with an interface and a class, except for one small detail. So if we go to model and we say add and class, all right, then there we type in its name, okay, fruit eater, enter. And instead of having to sort of search for interface and click on it, we just created it as a class. But now all we need to do is just double click on class and change it to interface. All right, and we've got an interface, okay. Again, perhaps your interface might be used by external objects, programs and so forth, so then you would make it public. But like I said, all this will be discussed when we create a DLL in a future video. All right, so we've got something called a fruit eater. It's an interface, and similar to a class, you have to give it certain, let's say, properties, for instance. Let's say, for instance, it has a property of, you don't have to specify public, because all interfaces assume you specify in public, because interfaces only deal with public interfaces. So if you just say, for instance, grams per day, for instance, as a property. So let's say it is a single, right? Because it can have a floating point behind it, 3.2 grams per day or whatever. So let's say a single grams per day eaten, or minimum. Let's call it minimum. So there's a minimum number of grams per day that this creature, a fruit eater, must get. Minimum. Okay, minimum grams per day, and we say, well, it is a get and set. All right. Okay, and so you can have others. All right. Let's give it one more. Let's say is it a forest bird? All right, which is just a true or false. All right, so let me say boolean, and we say is forest. Well, this fruit eater might not actually relate only to birds. It could be bats, it could be all sorts of things that eat fruit. So we shouldn't say is it a forest bird. What we should rather say is forest based. All right. Which is a true or false, so that this fruit eater comes from a forest. So you can use the same interface on not only birds, but anything that's a fruit eater. Okay, so let's say we've got those two things. You can do the same now. For instance, let's say there's a method that you want on your interface as well, a public method, and you say it's got no return value, and it's called let's say go drink water. Go drink water. All right, that's the name of our method. All right, and now normally here you would put in a body and start typing how to go and drink water. All right, but since this we want as part of our interface, all right, we just specified we don't give it a body. We just say semicolon and that's it. So there's no braces behind it. So that tells the interface, well, okay, so we've got 3 items in our interface. Minimum grams per day, is forest based, and go drink water. So go drink water is a function, and the other 2 are just properties. So if we come back to our Parrot, for instance, all right. So our Parrot is a fruit eater. Let me just pretend that I haven't added the interfaces yet. Okay, so now we think, okay, so our Parrot is a bird, and we've inherited from bird, but it also isn't specific a fruit eater, all right? But we can't inherit from fruit eater now. We can only implement it. So you write your class, all right, what you want to implement or inherit from, if there is one you want to. Maybe you don't want to, but whatever's in the list, okay? So it's like a fruit eater. He sees that as, well, that's an interface that we're trying to implement. But the thing is underlined it in red, all right? So we had no problems before with Parrot. Now suddenly, now that we add this interface, we've got a problem. And it tells us here, Parrot does not implement interface member minimum grams per day, is forest based, nor the method go drink water. None of them are implemented. So it's basically telling us that we have to implement those things. We have to now write code for that. You can right mouse click on fruit eater, okay, and so what you can do, like in the good old days, I can't remember, I think it was a shortcut key or something, but now you can physically sit down and write out all the code as is required by a fruit eater. So you got to write these actual properties, you got to write that function and put code inside it. Alternatively, a quick way you can do it nowadays is you can right mouse click on fruit eater, all right, and then go to quick actions and refactorings, okay, and then we say implement interface, all right, and it'll go and create all those things for us. All right, so I don't always like the way it does it, like, yeah, it's got all these throw exceptions and so forth, but this is all valid code. Or you could have just done it by hand. All right, now if I'd done it by hand, I wouldn't worry about throwing all these exceptions at the moment. I would just do it like this, the way you already used to it. No difference, it's just not throwing exceptions. And set like that. All right, so what we've done is we've implemented, this is what you term when you're dealing with interfaces. Fruit eater has got three items in its interface. Minimum grams per day, is forest based, and go drink water, okay? And currently if the go drink water gets called, okay, by some consuming code, it'll throw an exception saying it's not implemented, just meaning that we haven't written anything yet, and it's just telling us, hey, there's something wrong in the program, you must still write something here. So yeah, you can write some code, whatever it is, some pseudocode here, write code to get water. What we can do, since it's pseudocode, is search for nearest water source. All right, so the first thing it's going to do is going to search for the nearest water source, and then it's going to go and get water. Let's say go get water. All right, so there's a little bit of pseudocode for you. Okay, so now remember we've got animal, okay, and bird, okay, and they share the exact same public interface. The reason for that is that bird inherits from animal, okay. Then we have Parrot, which also has the same public interface, all right, as bird and as an animal, because it inherits from bird. All right. However, it's got an additional interface, okay, which it got from fruit eater, okay, that interface. So its public interface can actually be contacted in more than one way. You can talk to it as a bird, you can talk to it as an animal, or if you talk to it as a parrot, you can also call the fruit eater methods. All right. So this is where the polymorphism comes in, and you can have multiple different interfaces, and you can interact with this object of yours using those different interfaces. So let's say, for instance, if I go back to the main program, all right, so let's say now I've got a parrot. Well, firstly, we created an animal here just now, all right. So if I say a dot, all right, we get what we expected, number of legs, eyes, and the move object method, all right. But now on Parrot, remember, I still expect to see those same public interface items that we just looked at. All right, Parrot, and there they go. Number of legs, eyes, and move. But it also is forest-based, go drink water, and minimum grams per day. Nothing else has that. I mean, if you go and create an instance of a bird, all right, let's just create a bird. Will it be this time? And bird. All right, so if we say b dot, you'll also find, no, it's only got the same public interface as what it's inherited from animal. All right, so Parrot, in our current scenario, is the only animal that has anything to do with eating fruit. It's a fruit eater. And then it's got a method on it which says, you know, you must go drink water. Okay, and then that's interfaces. Now, the last thing I'll show you what interfaces allows you to do, which is very, very nice, is let's say, for instance, you have an array, all right? Now, remember, an array can only store the same data types, all right? So if you create, let's say, a bunch of ints, all right, an array of ints, just call it an array, and yeah, let's just call it my array, all right, equals, how did I do this again, new int, and then it is, let's say 10, okay. All right, so we've created an array, okay, or that can take a total of 10 objects inside it. Those objects are of type int. Okay, so if I add int to this array, so let's say I say my array, the very first one, index 0, okay, is equal to 23. Everything will be fine, all right, because that is an integer. But let's say I don't make it an integer, I make it a floating point number, 23.4, all right, then he's going to complain. You see it's underlined it in red because that's no longer an integer. Our data type is not correct. Okay, so what do we do? Like, let's say, for instance, we want a list of a whole lot of animals. Okay, well, let's just first say, what did I just do here now? Let's just say we actually want a list of parrots. Okay, so we create a list of parrots. An array of parrots, sorry, not a list, all right, and we add sorry, that's why. Okay, so that must be parrot, and then why is parallel written here? It's parrot. Okay, come on, parrot. All right, so we created now an array that takes not ints, all right, but type parrots. Okay, so if I say my very first item in my array is going to be a parrot, all right, a new parrot, all right, I can just say, for instance, new parrot. Okay, open and close. Okay, and it takes no parameters, all right. But now I can, so the very first item is a parrot, all right. This, the second, the third, the fourth, the fifth, those items have got nothing in it yet. Okay, they're null. All right, that's a default for an object. If it was like an int, the default will be naught. If it's an object, the default is null. All right, so we've basically got 1 parrot and 9 nulls in this one-dimensional array. But let's say now, I don't actually want to store parrots only. I want to store parrots and all other birds. So hang on a second. Do I have to now change? Do I have to create a new array for birds and then add parrots to parrots and birds to birds arrays? How can I go about doing this? So, well, let's go and have a look. So let's add to our current array, all right, a new bird, okay, or a new bird, all right. Not a specific type. We're just creating a bird, all right. Oops, okay. And firstly, we must just change this, okay. And it's giving us a problem, all right. So what is that problem? It says you cannot convert type bird to parrot. Now, the reason it's saying that is because you declared the array as parrots, all right, and you're trying to add a bird to it, okay, which you can't do, all right. But you say, but a bird and a parrot, they're both birds. Yes, you're correct. But so what you must do is, instead, if you want them both in the same array, you must find that which is common amongst them and make that your array type. So what is common between a bird and a parrot? Well, they both have the same bird interface. So if I change this parrot to bird, okay, did I put a double D there? Yes, all right. And then come here and I'll also say bird, all right. Then there we go. Now there's no problem. Now I've got a parrot and a bird added to the system. All right, but let's say, for instance, I want a collection of all the animals in my entire zoo. Now remember, they might be birds, they might be snakes, they might be sharks, tortoises, you know, lizards, geckos, aardvarks, etc. So how on earth am I going to add them all to one array? Well, what is the common thing amongst all of them? Well, animal. Okay. So I can, if I change this bird to animal, all right, then all animals in my entire zoo can be put in my array. All right. And you'll have no problems. I mean, you can even just you can just create an animal. You don't even have to create a shark. And we haven't created a class for a shark yet, but what I'm saying is, to give you an idea, you can just stick in here, for instance, anything of type animal, and everything will work just fine. But now, okay, let's say, for instance, so you've got all these different types of animals in your array, but you can only refer to them as animals. In other words, with the interface animal. So if I take array 0, which is actually a parrot, all right. Now remember, Parrot has got a few extra, or it's got a different interface on it with a fruit eater. So if I say array 0, which is an animal, and I say dot, okay, it'll show me my move, number of eyes, and number of legs, because that is what is on the interface for animal, and this data type in the animal array is of type animal. So I can speak to all these things in this array only as of type animal. But what I can do is I can do a cast, all right? So I can say I want to create a new data type, parrot, and I can call it, let's just say the old parrot, all right? Let's get it out of the array again, all right? And so old parrot equals 0, all right? And you could say at this point as parrot, all right, that's one place you can say it, and it'll return a null if it's not a parrot. Alternatively, you could, instead of writing it at the end there, you could do it here and say parrot, all right. But that may cause a problem if it cannot do the cast. But we know that it is a parrot, so we're okay with it. So if I now go and I look at old parrot, the one we just converted or cast, okay, if I say dot now, all right, there are all my parrot stuff back again. Go drink water, is forest based, and so forth. So what it comes down to is you can use an array, all right, which can only store one data type. It's got to be the same data type. You can use it, that tricking it through interfaces and polymorphism, you can actually make it save all sorts of other animals as well, as long as they're all of type animal or whatever you just said your array is. Now, just for interest's sake, guys, arrays are very used and so forth in multiple languages and so forth. But one thing that C# has that we tend to use more often, for if you just want a quick list or something, or an array, all right, is to actually use what they call the generic list. Okay. In order to be able to use it, you do need this. You see up top here saying using system collections.generic. Right, that must be on the top of your file there. Usually it is there, so you don't need to worry about it, but it might not be there. So what you can do is, instead of adding all these things to an array, all right, and the problem with an array is if you say there's 10 items in an array, let's say you fill up all 10, 0, 1, 2, 3, up to 9. Now you want to add 4 more. Well, now you're in problems. Now you've got to recreate the array, all right? You've got to like somehow know that it's got to be by 4 more up front. Array just gives you problems with that. So you do have an array type, but what I'm trying to get you to use here now is what we call a generic list. This is what most programmers use nowadays. So you just say, you can say iList, but you just say list, all right? And then in little bigger than smaller than signs, this is what you use in C# when you're using generics. Okay, I'm not talking about when you're doing Boolean evaluations. This is not what it is. Okay, so I'm saying I want a list of type animal. All right, animal. All right, and I say it's the name is my and new list animal. Okay, the only thing that you have to add, which it didn't do for you when you did the code completion here, is you got to open and close with a parenthesis. All right, now it works the exact same basically as a array. You can index it and so forth, but you don't have to do it that way. But let's say your first, your first 3 are, let's say, well, your original array was, let's say 10. But let's just, for ease, just say it was 3. So that means now on the original array, my array is full. Okay, I can't add any more animals to it. But since this is no longer a normal array, this is a generic list that accepts typed animals. The way you add to a generic list, okay, is you say list, your variable name, my array dot add. All right, you see add there. Okay, and then the object you want to add. So let's say new parrot. New parrot. All right, so in other words, all this should be replaced with this. All right, so we had new parrot, and right at the end was animal. All right, so that means that this was bird. All right, so what's nice here is with an array, with an array you are limited up front with what's the size of the array. You have to know. All right, with a list you don't need to know. It's fast, okay, it does things very quick, but it's not as fast as an array. But I mean, really, the difference, it's not really for general programming from day to day. I recommend you use the generic list. You can use iList or IEnumerable or just list, like I did in this case. And this is called the generic list. Generic is referring to the fact that it can handle many different types, data types as a list. So if it's, you can say list animal, you can say list int, you can say list bird, list car, list my hot rod, list whatever. It's generic. It can be for anything. And okay, so that's that. Okay, so the very last thing I'm going to be looking at today is, if you remember a little while ago, a few minutes ago, about an hour ago, I don't know, I mentioned that we have, for instance, an animal, a bird, and then a parrot. But an animal itself should not be able to exist and a bird should neither exist. You have to specify like what bird, what animal. Is it a zebra, a chameleon? You can't just create an instance of an animal. All right. There's no such thing as something walking around which is an animal. There's a class of things which are referred to as animals. There's a class of things referred to as birds, which happen to be animals. And so, but right down at the bottom, you get, like, for instance, if you think about animals in real life, what is it? Phylum, class, order, family, genus, and species. The species is the last thing that actually really exists. Okay. So the same thing applies with the classes you use in your programming. So in other words, in a real zoo, all right, if I now had all these animals and they were in a real zoo, I should not be allowed to create an instance of an animal. All right, I should be allowed to create an instance of a macaw or a shark, something like that, but not of an animal. Okay. Because that's not a real thing, okay? That's just defining how something else is going to be created. So if we come again and we look, for instance, here at animal, all right? So the way to prevent this thing from ever actually being created an instance of is to type the words in front of it, abstract. All right. So now that's saying that this animal class you cannot create an instance of. Okay. So if we come and look, okay, here where we're adding to our list, we added a parrot, we added a bird, and we added an animal. Animal is now giving us a problem. Okay. Because we're creating a new animal here, and you're not allowed to create a new animal. You're not allowed to do anything with an animal other than inherit from it. So, like if you go to bird, for instance, all right, bird is still fine, okay, because bird is not defined as abstract, okay, animal is abstract, but not bird. So if we go into bird and we look at bird, all right, we'll see it inherits from animal, which it's allowed to do. You may inherit from abstract classes, but it itself, okay, is not abstract, all right. So it says you can create an instance of a bird, which actually is also not true. You should not be able to. So we make that abstract as well, all right? And if we come and look at our adding to the array here now, to the generic list, we find bird and animal are giving us problems. Okay, but parrot isn't. And parrot inherits from bird, which inherits from animal. So what it's basically saying, what abstract is doing is saying is you're not allowed to inherit from me. You're not allowed to create an instance of me, but you are allowed to inherit from me, which is kind of more realistic. That's more of what you want. A zoo doesn't have things walking around like just, completely not really defined as it is a zebra or a ant. So yes. The other side of the coin then is also what you can get on classes is, for instance, to say sealed. All right. So with sealed, it's a little bit different. It now says, okay, you may not inherit from me. Okay. So abstract says you may create an instance of me. You may only inherit from me. And sealed is saying you may not inherit from me, okay? But you may create an instance of me. So they sometimes are sealed in an interview question. I don't really see why that's such important knowledge, but all right. I'd much rather you know what abstract classes are. But okay. So when we get to an abstract class, all right, there are certain things in an abstract class, for instance, that you don't want to define within the class itself. So let's just change this back to an abstract class, not a sealed class, abstract. Come on, did I mess up here now? Let's make it so it's an abstract class. All right, so animal is an abstract class and it's got eyes, legs, okay, and move. All right, but let's say, for instance, move is something which you know, you could put code inside here now, all right, to make it move. But no one really knows, like, what animal is it? How does it move? You know, if it was a snake animal, then the instructions inside the move command will be different than if it was an elephant animal. You know, the way they move are different, or a bird flying is different. Okay, so what you can do is rather, instead of having an implementation of this method, is to make it, to say that it's abstract. All right, so let's just, where am I messing up here now? So let's just get rid of the method body, put a semicolon at the end, and say it's of type abstract. All right, and what that is now saying is that whatever is inheriting from animal, okay, must have a move in it, and it must put code in it. Okay, so the actual animal abstract class just says there must be a move, but doesn't really know how to move. Okay, so it's similar just to an interface here. It's just saying you must have a move. All right, so if you look at a bird then, and if you remember that it also is an abstract class, in other words, not allowed to create an instance of a bird. So you main create an instance of an animal, you main create an instance of a bird directly itself either. But now if you remember, on animal, okay, we had that move method. All right, here's that function, okay, but we said it was an abstract. Okay, so that says whoever is inheriting from animal, all right, must implement a method named move. Okay, but then I am now in a class that's inheriting from animal, but it's not giving me any errors. It's not telling me I need to create a move. Okay, the reason for that is because I made it also an abstract. If I take that abstract out, you'll notice that in a second, bird is underlined, and it tells me bird does not implement inherited abstract member move. All right, so because it's not an abstract class itself, it says, sorry, you cannot continue. You now have to create the move method. But it's also an abstract class, so I'm completely okay with not having a move method. All right, I'll leave that rather up to the actual specific bird that I'm dealing with. And that's the case. So if I go to Parrot now, for instance, you'll notice Parrot is underlined. All right, because Parrot inherits from bird, which is an abstract, and it inherits from animal, which is an abstract. So therefore move from animal to bird, and now it's reached Parrot. But because Parrot is not abstract, it has to implement move. All right, and that's the error we're getting. Parrot does not implement inherited abstract member animal.move. All right, so you need to add animal.move, and this is where you can add the move specific stuff for a parrot, and maybe it's a move for a seal or for a snake. Then it's a very specific way that the movement that gets done. So it's forcing you to create the method called move due to the abstract classes that it's inheriting from. But it's only at this point where you decide what code goes in there, which all right, we'll create now. So it's telling us, let's just make sure again. So it's telling us that the method move, all right, from animal, that is not implemented. So all right, so what we need to do is we need to say it's a public. So public, it is override. Okay, saying override the one that was declared in the abstract, and then it is what do I call it? Just move, yeah, move. All right, and it just, okay, it happened to fill in the code for me, but what it basically did is it stuck in the correct variable types. I think I called mine int16s, but u short is the exact same thing. It's just another way of writing it. And I prefer normally saying like u16 or 32 or whatever. I don't know how many bits I'm dealing with, but it doesn't really matter. So what I've basically done is I've now created this move method that was originally declared as an abstract method in the abstract class animal. And I can now come in here and write some pseudocode that relates to write code on how a parrot moves. Okay, and that's that. So if I go through my my generic list that I had over here, let's just get rid of these two bad birds here. And well, and we can add another parrot if you want, just so that I can show, you know, for fun we can add 50 parrots, you know, for let's do that quick. For int I equals naught. Why does this always happen to me? Int I equals naught, and then it's I is smaller than 50, and then it's I plus plus, declare the body. Okay, so what this will go ahead and do now is to my array, it's going to add 50 parrots. Okay, and I can, all right, for instance, at this point here, let's say I access the 10th one, all right, or the 12th one, or whichever one. Okay, I can now go and say, okay, old parrot, I want you to move. All right, oops, come on, dot move. All right, so there's the move method. All right, and it's asking me for speed in meters per second. So let's say it is 1.5 meters per second, and I want you to travel for a distance of 10 meters. All right, and that's it. So I've told the parrot to, oh, hang on, it's use short, so it doesn't allow floating point numbers. Okay, so let's just say, all right, 2. Okay, so I told the parrot now to move. Okay, and inside this move method now for a parrot, the way I started writing this code here, the pseudocode, right? Yeah, you can now start writing your real code. What happens when a parrot moves? And okay, and I think sure that was a long one, guys. I think we call it a day on that. There are definitely more things I can tell you about object-oriented programming, but I think in order to know OOP just beyond the basics and know it at a point high enough to actually say you can code in it, but not necessarily be an absolute fundi. But if you know everything I told you now, you will definitely be considered a full-blown object-oriented programmer. There are some things that I didn't include, but you know, you can't do absolutely everything. So well done if you've reached this point, and even more well done if it's made any sense to you. And yes, I'll catch you again in the next video. And have a good day, guys. See you, my man. Bye-bye.